All right, new to this section is the concept of an antiderivative. A function f is called the antiderivative if, when you differentiate it, you end up with the function you're being asked to find an antiderivative for. Okay, and we're going to have a couple of different rules for this, but let's look at a couple of examples that would make some sense. In this first example, we're asked to find three antiderivatives for f of x equals 4x. Now again, we're looking for three different functions that when we differentiate them, we end up with 4x. It's important to note that there isn't just one antiderivative. There's always multiple options. In fact, an infinite number of options for the antiderivative. To do this, we're going to have a rule in a second, which I call the anti-power rule. But let's talk about what we could have, and you take some guesses to do this. If we had something like x to the fourth and differentiated that, we would get that 4 out front, but we would have an x cubed. And knowing that when we differentiate, we always lose a power. With that in mind, I need to have an x squared function, our degree 2 polynomial here. So I'll start with the x squared, but now when I differentiate x squared, I would get 2x. But if I throw a coefficient of 2 in front of this, I now have a function that when I differentiate would give me 4x. So this would be my first antiderivative. And then a trick with antiderivatives is, well, if I have my first kind of my foundational antiderivative, any version of that that has a different constant, like 2x squared plus 5, or in the third version, 2x squared minus 10, all of those have, when I differentiate, would give me 4x. And importantly, remember is that when I differentiate, my constant term becomes 0. So all three of these, when I differentiate them and checking them, when I differentiate, I end up with 4x. So these are my antiderivatives.